Hello and welcome back to lecture number 5 of our Python programming course. Let's go ahead and see what we're going to learn today. Today we are going to dive into chapters 11 and 12, and we're going to explore some more built-in data structures in Python, the first one being dictionaries and the second being what is called a tuple. We're going to look at the different aspects of dictionaries and tuples and how they're the same and how they're different. So let's go ahead and just get started. A dictionary is considered one of Python's best features, and it is like a list, except in the fact that it is pairs of data. So one of the items is a key or the index into the dictionary. So if you think of a dictionary, it would be the dictionary word. And then the second part of that is the value or the item, or sometimes it's called a key value pair. And that is that value that is associated in some way, shape, or form to the key. Again, if we're going to use that dictionary example, it would be the dictionary definition of the dictionary word. In a dictionary, you are going to map from keys to these values. Python has a built-in function that creates a dictionary, and this function is dict. There are a few different ways to use it. If I am at the command prompt, I can set a variable equal to dict and then just an open and close parenthesis. Then if I were to print out that variable, it would show me the curly brackets just blank, nothing in there. That's called an empty dictionary. Now I can add a value to a dictionary by using that variable again, and in square brackets, instead of putting a number like we do with a list, I'm actually going to put a key in quotes. So our indices in this case would be string. And then I can say it is equal to and a value. Now if I were to print out this dictionary, it would give me within those curly brackets the key and then a colon and then the value. So this key is said to map to the value that we gave it. And the value is that key value pair that we spoke of before. The key here is that colon, and that is what is going to be associating those two values together. I can also add multiple items to a dictionary at one time. So in this case, I say my variable equals, and I have the open and close curly brackets. And I say 1, 2, and then comma. So there's a comma separating each of the key value pairs, and then the colon separates the key from the value. So now if I were to say output whatever that variable is, I would see something very similar to what I used as the input. I'll see the open and close curly brackets, and then within there, each pair separated by the comma, and then the key and the value separated by the colon. One thing that you can see though is I input 1, 2, and then 3. Why did this output 1, 3, and then 2? Well, in a dictionary, the order of your items is unpredictable because that's not the point of having a dictionary. In a dictionary, your order does not matter. The index number is not a thing. We find our values by using our keys instead. There are a few different built-in functions for dictionaries that allow me to see how many items are in my dictionary. The first one I have is a function called len, which stands for length. If I send it a variable, it will tell me how many of those key value pairs are in that dictionary. So the one I just created, which had 1, 2, and 3, uno, dos, tres, has 3. I can also use that in function. So if I say 1 in my variable, 1 is a key into my dictionary, so it will return a true. If I say 4 in variable, it will return false because 4 is not a key in my dictionary. Lastly, I can get a list of all of the values that I have stored in my dictionary. To do this, I use my dot notation on my dictionary variable. So here, I have set a variable values equal to the variable dot values. After I get those values, I can then say uno in values. If we're going back to the dictionary I created in the previous slide, uno is one of the values, so it would return a true. A dictionary can be looked at as a collection of counters. And by collection of counters, I mean if we are trying to count something. For example, if I have a string sentence and I want to see how many of each letter I have in that full sentence, I can do it many different ways. The first way is I can do it with variables. I could create 26 variables, one variable per letter, and traverse the string character by character and increment the variable of the correct letter. So for example, if I find an A, I can say my A variable equals A plus 1. And I can do that for every character in my string. I can do the same thing with a list. If I were to do it with a list, I would have one list with 26 elements, one for each letter. I can then strategically do it so that my index reflects the letter, and so I can convert my character to a number and then use that number as the index into the list. Once I find the proper location in my list, I can then increment the counter at that letter. The easiest way to do it is I can implement it with our new dictionary technique. You will have one dictionary. Your characters will be keys, and you can have a value that will contain the count of that letter value. The nice thing about the dictionary way is that in the dictionary you can add the item to the dictionary the first time it is found and set its value equal to 1, and then increment counters as you find the letters. So with a dictionary, you are only going to hold the keys of the characters that you find. In using the variable technique and the list technique, you are going to have extra memory taken up by letters that may or may not exist in your sentence at all. In the dictionary technique, you're only going to have and you're only going to take up memory for the characters that you actually have account for. This is actually going to make your dictionary the version that you'll want to use. Let's take a look at an implementation of just such a counter. So remember, we are taking in a string and we are counting each of the letters and how often they occurred. Here I'm creating a function called letter counter and I'm sending it a string. The first line of code within the function letter count equals dictionary is going to create an empty dictionary. Then we're going to do a for loop to traverse the string. So for character in the string send. What that's going to do is it is going to set character equal to each character in that string, going from the very first character through the very last. If the character is not already in the dictionary, it is going to add it to the dictionary and give it a value of 1. So here we do that by saying letter count with character in square brackets, and we set it a value of 1. If the character is already in the dictionary, so that would be the else part, add another count to it. So for here, we'd say letter count of character plus equals 1, and that will take whatever value's in there and add 1 more to it. Finally, this function is going to return the dictionary with your key values being the characters and then the key value pair being the number of times that character appears in the string that was sent. We can use dictionaries in a few different ways. So the first one that we have here is looping through the dictionary. And this will take a dictionary and you can say for C in H, H is my dictionary, C would be my key, print C and then H of C. So it would just print key value on each line. And you can loop through the dictionary going from whatever the first key is to whatever the last is. You can also do what's called a reverse lookup. And a reverse lookup is going to use a value to find the key instead of using the key to find a value. What I do in this case is that I take D, which is the dictionary, and V, which is the value I'm looking for, and I say for K in that dictionary, if the value equals V, return K. So it will return the key associated with that value. Dictionaries and lists are different, but you can have a dictionary that has a list as a value. So for example, here I've got my dictionary has a value of key value of 1 and 2, and the value associated with key 1 is actually a list of APTO, and the value associated with number 2 is an R. So here we can see we have a function that we created called histogram, and it is going to be given A1, P1, R2, T1, 0, 1. I can do the inverse of this then to make the key the count of the character and then the value the character itself. If I do that, 1 is then going to have A, P, T, and O as shown here. And then 2 would have the list R. So you can combine dictionaries and lists. Tuples are one more built-in data type in Python, and a tuple is a sequence of values. Your values can be of any type. You're going to index them by using integers. And tuples are very similar to a list, except that they are immutable. Remember, immutable means it cannot change values no matter what. If I want to use tuples, I have two different ways of creating them. The first way is just to give a variable equal to a list of comma separated values, or I can enclose those comma separated values within parentheses. They both do the same thing. Here, if I say T1 equals A and I put a comma at the end with nothing following the comma, it is going to take that then as a tuple and not as a string. Here, if I say T2 equals A, and remember, I don't have that comma, it will take it just as a basic string. That's not what we're looking at. We want to make sure we add that comma at the end of our tuple. I can also create a tuple by saying T equals tuple with an open close bracket. I can also create a tuple by sending it some values or a string. If I send it a string, it will create a tuple using each of the characters. So here my tuple is LUPINS. List operators will also work on tuples. So here, if I have my tuple T and I say T square bracket 0, that is looking for index 0, which in this case is going to be A. I can also take a slice of the tuple, just as we took a slice of a list before, of a 1 and 3. So it will take 1 and 2. Now, the one thing, remember, it's immutable, so it cannot change. So I cannot give the index 0 within a tuple a new value. The object doesn't support item assignment. That's not something I can do. I can't change it. But what I can do is I can append onto the end of the tuple. So here I've got T equals, this creates a tuple, and then that will add on to it, the original. So if I take the original that I have here and put the capital A in front of it, and then take a slice starting at 1, B, C, D, E. It will allow you to make changes in that way. I can also compare tuples. So if I have tuple A is less than tuple B, the answer is true because 1 is less than 3. And here I also am able to do that. But notice that even though this last number is a lot larger than the last number here, it stopped at the second value. So 1 is still less than 3, so it is still giving me true. I can assign tuples in a few different ways. So the first way would be to use an extra variable in order to move an assignment around. So here I have a temporary variable. I set it equal to A. I set my A equal to B, and then my B equal to my temporary. There is a more slick, fancy way of doing a tuple assignment, and we do this by doing A comma B equals B comma A. These two commands are going to do the exact same thing. This is just going to do it using the tuple methods that are buried within it. I can also split a tuple. So here I've got an address with an email address, so monty@python.org. I can then say my name, comma, domain equals address, split it at the @ sign. It's then going to make uname the Monty part and then the domain, the python.org. So here I was able to give it multiple variables on one line because it's a tuple and use my split and send it the delimiter. I can also return tuples. So for example, there are built-in functions. There's one called divmod, divmod. Here I have a tuple the div mod of 7 and 3, and it's going to give me back a 2 and a 1. The div mod function is a function that is going to take 2 arguments and then return a tuple. And the 2 values in the tuple are going to be the quotient and the remainder. So for example, if I take 7 and divide it by 3, I get 2 with 1 left over. That's where my tuple of 2, 1 comes from. I can also use my tuple assignment to break out the quotient and the remainder into 2 separate variables. So for example, here I have quote, comma, rem equals the div mod of 7, comma, 3. It's going to give quote the quotient of 2 and rem the remainder of 1. It's kind of a slick way to do your division without needing to do the 2 steps of the mod and the divide. You can do it all in one. So for example, if I want to create a function that returns a tuple, I'm going to define it like I do here, min and max, and it's going to return min, comma, max, which is then going to create the tuple. So this top one up here returns that tuple as 2 values in 1, or I can put it in 1 variable. The second one is going to store each of those elements of the tuple that are returned as a separate variable. So I've got 2 variables. And this bottom one is just an example of a way to use the return with the tuple from a user-defined function. I can also use tuples as arguments into functions. If the function argument is going to start with the character of a asterisk or a star, that is going to take all of the arguments being passed to it and gather them all up and create a tuple. So here, for example, if I have def, I'm defining a function called print all. I'm sending to it a star arguments, and it's going to take every argument that is sent, and it's going to then print them out. When I do that, it's going to print a tuple of all of those put together as a single tuple. These methods are nice when you don't know how many arguments you're going to have and you just want to take all of them and then do something with them. Now, the opposite of the gather is the scatter. So instead of putting them all together by gathering, I'm going to take the tuple and create individual elements. That's what a star t being sent to a function is going to do. So if you remember that div mod takes 2 values. Well, in this case, if I send it star t, it's going to take that tuple t and divide it up into 2 values. I can work with lists and tuples. Tuples have a zip function, and that is going to combine 2 or more sequences by zipping them together. And your result is going to be an object of type zip. Now, the way that it does it is that it will pair one as the key and the other as the value, and it'll pair them up. So it's not going to just take S, A, B, C, and T, 0, 1, 2, and put one after the other. What it's going to do is it's going to take the A and associate it with the 0, B associate it with the 1, and then the C and associate it with the 2. So you can see how it kind of lines up like a zipper on your clothing does. Then if I say print the list of whatever is zipped, I can get something that looks like this. I can also iterate through a zip. And I do that just like I would if I were trying to iterate through a dictionary or a tuple or a list. For each pair in, and I zip two lists together. And then I can just print the pair. So it will take the first pair, which is A and 0, and then print B1 and C2. So it's just going to march down this zip and give me each corresponding pair that goes with it. So here I've got S is a list and T is a tuple. So remember, I can do two or more of any type sequence. They don't have to be the same. Now, dictionary functions have something called items, and that is going to return the sequence of tuples where each tuple is going to be a key value pair. So in essence, you're kind of converting between the two. So here, if I have a dictionary D that is my A0, B1, C2, I can then say T equals the dictionary.items. It's going to take that dictionary and create a tuple of it, where it's going to be C2, A0, B1. Now remember, my order in this is going to be wonky. It's not going to be very reliable, but it doesn't matter. I can then look through it by saying for key and value in that tuple, print it out. That is going to create an item object, and therefore we can go through each of the values within that item object. That is all I have for dictionaries and tuples, and I hope you were able to learn something new in this lecture today. I will see you next time for lecture 6.